All right, in this segment, we're going to look at some problems and practice coming up with the claim and alpha and developing the hypotheses. So let me go share a document that includes some problems. And we'll work from here. Now, we've got a problem here, and this has been all worked out. I'm not going to show you the process. I'm just basically going to identify what you need to be aware of here and what you need to look for. And you'll refer to the table that we showed in step 1 in the last video to come up with what relationship should be in the claim and in the hypotheses. So in the wording of any kind of a hypothesis test problem or hypothesis test related problems, a problem that has a question about a hypothesis test, you're going to be given a significance level, which is the alpha, and you'll need to remember the term significance level, and you'll also be given something that identifies the claim, okay? Along with some other stuff. We'll worry about the other stuff in future videos, but let's just figure that we're looking for the claim right now and alpha. And then from that, we'll develop our hypotheses. So in this problem, we see a highway patrol randomly selects 23 cars passing a point on the highway and measures their speed. The mean speed was 69.3 miles per hour, and the standard deviation of the speeds was 7 miles per hour. That doesn't say anything about making a statement about a parameter. That just means they're collecting some data and doing some calculations with the data. Let's look at the next sentence. Test at the point alpha equals 0.05 level that the mean speed of all cars passing this point is less than 70 miles per hour. So the key words that we're looking here for in this problem, we see test that. And then it'll test, we're testing that the mean, test that the mean, and I've highlighted this in yellow because this is the important claim information. Test that the mean is less than 70. That kind of tells us the 3 parts of a hypothesis test. First it says we're talking about a claim when it says test that. And then it gives us a parameter in the population, mean, okay? The mean, and it gives us a relationship, is less than, and then it gives us a value, 70. So those 3 pieces of information are there. First, we identify that this is a statement about a claim, and it may, some of the problems may actually say claim, but what we're looking at is a statement that gives us a parameter and a relationship and a value. And it also gives us alpha, that unlikely probability. So alpha is 0.05, that's the significance level. So in this table that I've got here, and by the way, in the notes, there is a blank table for all of these problems. And you might want to print that out and fill it in as we go when we work through these problems, because we'll work through these at each step, fill in the appropriate information at each step. So we got alpha equals 0.05. Well, here's alpha, we'll put in 0.05, okay? Then we know we're talking about the mean, and where we know what's the mean symbol. The mean symbol is mu, that Greek letter, lowercase Greek m, mu. And so we're going to put the parameter here, mu, and the relationship is less than, so less than, that's a symbol for less than. And 70, that is the value, so we'll put 70. So we've got our claim. Then going to the table, if you recall from the table, the alternate hypothesis and the null hypothesis and the alternate hypothesis both have the same parameter So they'll both have mu, both have the same value, so we'll both have 70. And we know that all of the null hypotheses will have equals. It's always going to be equal. So we know that we're going to have mu equals 70. There's no argument about what this is going to be, what this relationship is in the null hypothesis. It's always equal. And then we've got in the alternate hypothesis, again, mu and 70. And remember, the claim does not have an equals part. It's strictly less than, which means that the relationship in H1 is less than. So mu less than 70. And because the null did not have a less or a greater or an equals part, then H1 is basically the claim. Okay. Remember, one of these two will be the claim, and since there is no equals part in the claim, H1 is the claim. All right, let's go to another problem. An aircraft radar system must measure the range to a target with a standard deviation of at most 1 meter. An experiment where 51 target ranges were measured by the radar resulted in a standard deviation of 1.2 meters. And it looks like information about collecting data and calculating something. That's not what a claim looks like. Our claim comes in this next highlighted section. Test that, and here at the 0.01 level, doesn't say alpha, but it's talking about a level. Alpha and significance level all mean we're talking about the significance level. So the significance level is alpha, and in this case is 0.01. But we're testing that, so we know we're talking about the claim here, even though it doesn't say claim, that standard deviation is greater than 1. So we've got a parameter, we've got a relationship, and we have a number. Sigma is the parameter. Greater than means is this symbol, and 1. So we have our claim, and we take this out, 0.01, we know that's the significance level, we know that's alpha, and so alpha equals 0.01. Then once we have our claim, sigma greater than 1, and again, this does not include an equals part, so let's continue on. H0 is always, it's going to have the same parameter, sigma, same value, 1, and it's going to be equals, always equal. Alternate, since this does not have an equals part, then it's going to be the same as the claim, sigma and 1, and same relationships, greater than, and it is basically the claim. Let's go to the next one. A measurement technology company wants to increase the precision of their measurements. A sample of 25 measurements from the new device is collected. The standard deviation of the sample is found to be 0.185. Assume that the device measurements are normally distributed. We can ignore that because that assumption will be met in virtually all the problems we'll deal with. And then we get to this statement, the blue highlighted statement up there. Again, it's talking about collecting some information and calculating statistics. But in the yellow highlighted, we see that, and these won't be highlighted in problems that you're given. You'll just have to think about them, highlight them yourself in some way. Test at the alpha equals 0.05 level that the true standard deviation is at most 0.15 millimeters. Well, test that means that we're talking about a claim. Okay, we've identified the part of the problem that is talking about the claim. Alpha equals 0.05, again, that's our significance level. And so we need to look at the rest of the statement. Test that the true standard deviation, so we got a parameter, standard deviation, is at most, there's our relationship, at most 0.15, and so we've got a value. So what do we have here? Sigma is our parameter, 0.15 is our value, and the relationship is at most, that means that number or fewer. So that means equal to that number or less than that number, which means it's less than or equal. So here is our claim. Now note that it has an equal part. It's less than or equal. And now we have the H0, same parameter, same value, and always equal. And since the claim has an equals part, then H0 is the claim. In the alternate hypothesis, sigma again, 0.15 again, but now since the claim has an equals part, the relationship is going to be the complement of the claim. Claim is less than or equal to means equal to a specific number and numbers to the left of it. Well, that leaves numbers to the right, which means this is greater than. Okay, let's go to another one. An insurance company report states that the mean age of automobiles on a road in the United States is equal to 6.67 years. A random sample of 31 cars had a mean of 5.65 years with a standard deviation of 1.2 years. Okay, that sentence right there, again, sample, collecting data, calculating things with it. That's not a claim. And then the last part, test the claim at the 0.05 level. Well, it says test the claim, but in that sentence right there, it only identifies alpha. It doesn't say what the claim is. The claim, you have to go back to the first part there to get the actual claim. Test the claim that the mean, again, this is the parameter. Test the claim that the mean parameter is equal to a number. So the relationship is equal to. So and the mean is mu again, mu equal to means equal to, and the number 6.67. Alpha again was 0.05. And now we're going to build H0 and H1. And remember, the claim includes equality. Therefore, the claim will be in H0. And we'll use mu because we always use the same parameter as we have in the claim. Same number, 6.67, and H0 is always equal. And that's what makes H0 the same as the claim in this case. The alternate, what's the complement of not equal, or of equal? It's not equal. Everything but equal, everything but that value. So mu, again, 6.67 again, but not equal. Okay, let's quickly go to the next one. And drug company claims that their new migraine drug is at least 70% successful in preventing migraines for a period of 6 months. An independent research company found that of 45 patients given the drug, 27 were migraine-free for 6 months. Test the drug company's claim at the 5% significance level. Okay, where's a sentence that talks about a claim? Well, we have the word claim up here. Here's where it tells us the actual, do the test the claim, the drug company's claim. So this claim right here is what is stated in that first sentence. And at the 5% significance level, well, 5% as a decimal is 0.05. So its significance level says this is alpha. Alpha and significance level mean the same thing. And it's 0.05. So what's the claim? Well, we put the alpha equals 0.05 in here. What is the claim itself? All right, claim that at least a migraine drug is at least 70% successful. Okay, doesn't talk about a mean, so it can't be an average of 70%. Doesn't talk about standard deviation, so it can't be a standard deviation of 70%. But it does give us a percent. And remember what proportions are. Proportions and percent are basically the same thing. And when we have a percent, basically we know it's a proportion because we have a percent. And it also gives us the number. 70% as a decimal is 0.7. We always take a percent and divide it by 100 to get the decimal value. So 0.70 is our value for the claim. So, and since we're talking about a percent, it's proportion. And what is the parameter for proportion? It is P. So we've got P and 7.7 for our number, but at least that number. What does at least mean? That means that number or more. So greater than or equal to. So there's our claim. And what is the, and notice it has an equals part. So the claim, H0 is going to be, again, we use the same parameter and the same value, P and 0.7, and the alternate, the null is always equal. So it is going to be the claim because the claim had an equal part. The alternate is going to use the same parameter, P, the same number, 0.7, but it's going, the relationship is going to be the complement of the relationship back over here. So it's going to be less than. Okay, one comment before we go to the last problem here. Going back up to the second and third problems, they're both about standard deviation. How do we know it's standard deviation? Well, it's easy for this problem because it says standard deviation. But the words might include something like varies or variance or something along those lines about variation, variation and varies, okay? Those words will imply that the parameter is standard deviation, okay? So you need to remember that. I forgot to mention that when I went through here. So we're going to go look now at the last problem, I think, and that is this one right here. A mayor of a large city was caught embezzling from a treasury. His approval rating was then reported to be 13%. Of a random sample of 200 people, 7.8% were found to approve of the mayor's job performance. That sounds like sample calculations. Okay, sample data and calculations. All right, let's look at the last sentence. Test at the 0.05 level, alpha equals 0.05. We got our alpha, so we might as well go ahead and put that over here. Test at the 0.05 level that the reported approval rating was not correct. Okay, we got to put our thinking caps here on. Put them on here. What is the reported approval rating? Well, that's why we have to go back up and look at the beginning part of the problem here. The approval rating was reported to be 13%. So here is a percent. Doesn't say mean, doesn't say standard deviation or anything like that. It just gives us a percent. That implies that it is a test of proportion that we're looking at. So it's going to be P. So our parameter is P. And 13%. So basically, we're testing at the 0.05 level that 13% was not correct. What does was not correct mean? Correct means it would be equal to 0.13. Not correct means it's going to be not equal. So our claim then is the parameter P is not equal to the value 0.13 as that's the 13% as a decimal. Again, does the claim have equality here? Have an equals part? No, not equal. Specifically, it rules out equal. So it is not, doesn't have an equals part. So an H0 is going to have the same parameter P, same value 0.13, but it is always going to be equal. So we put equals here. And the alternate hypothesis, since the original claim did not have an equals part, the alternate hypothesis is going to be the same as the claim. Same parameter, same value, same relationship. And again, it is the claim in this case. Okay, so we're going to continue on with these problems as we go through the remaining steps here. So this is practice for step 1.